I'm Claire. Today let's talk about these problems, and both of them about the cosine functions. Okay, so first let's see the first problem. So for any theta theta is a member of 0 to pi. And also for any a is the member of r. Actually, it's the real number. So we're going to prove there exists y that is the member of a minus theta to a plus theta. So such that cosine y is less or equal to theta. So we're going to prove it. Okay. So let's see. So let's think about the graph first. So we're going to about the graph. So we're going to draw the polar coordinate system, right? Okay, so now let's think. You see, theta belongs from 0 to pi, so we can't reach 0, right? So in the first moment, theta choice d theta, right? Because it's 0 plus d theta. Something like here. Okay, so let's think about a. Okay, let's think. Where's a? Maybe we say a is right here, over here. So this angle is A. Okay, so what's the next step? We think we're going to move these two guys, right? Okay, so the first thing is we're going to think what is the region, what is the domain that y can choose from a minus theta to a plus theta, and y can reach a minus theta and a plus theta. So let's see, if it's a minus theta, so theta starts from d theta, so a minus d theta. Okay, so now let's start to move. Okay, from a, from a minus d theta, and here's d theta, right? Okay, move. Okay, so from to here, then we stop, right? Because theta is 0 to pi. So from here, actually it's pi minus d theta. So a right here is this angle minus d theta. Okay. Just this place. Okay. So let's check another thing. If it's a plus d theta, so what happened? Okay, this is a, right? And this is theta. Okay, a plus d theta. Okay, we move on d theta, so it's also on d theta. Okay, it's right here. And then we move and we rotate. So we rotate right here. This is theta. Theta is right here, pi minus d theta. So a is over here, and we just minus a d theta, just over here, right? So like this. So we can imagine. Actually, what we're gonna think in this problem, it is a can choose any value. So in this polar coordinate system, so just any place in this circle. So theta is from 0 to pi. So we need to be sure that theta chooses one value from 0 to pi. Of course, a can choose any value, and we need to be sure that theta chooses one angle from 0 to pi, that we can let y and y belongs to this domain, is a member of this domain, so we can such that cosine y is less or equal to cosine theta. This is what I'm going to do. Okay, so we can imagine, if we look at this picture, you can imagine there's one place, because you see cosine y. So this, when we a minus theta, so these angles are what the y angles. So we can check about with theta. So some sort of like this, and keep going. So the part that it satisfies is that to here, because right here is equal. But if we go more, so then it's just been cosine y is greater than cosine theta, right? Okay, so, and if it's move together. So first, this one is less than first. So first, cosine y is less than cosine theta, and then we move, and from move to here, you see these two angles move to here. We can see when we move to, we can draw a line over here. We can draw a bisector. So when we let this bisector line, move to the horizon to here, so sounds like this one. Maybe it's over here. So when we move to here, then if we move one more, then remember this is theta and this is what? This is cosine y. And if we move one more, then cosine y is greater than cosine theta, right? So if it's a plus theta, so just which part we can satisfy is theta choice from 0 plus d theta to here, right? We can match something like this. Okay, so now what we're gonna do is we prove it in algebra. Okay, so when we're gonna prove in algebra, so first we see first we're gonna prove when theta is we break the domain, and from theta is a member of a domain, and we break the domain to two parts. So now we're gonna prove when theta is a member of let's see, from 0 to pi over 2. So if it's from 0 to pi over 2, okay. Now we're going to see, because we let y choose a minus theta and a plus theta. So you see, we're going to prove cosine y is less or equal to theta, cosine theta. So now our y choose a minus theta and a plus theta. So if y choose a minus theta, so that means cosine y, now it is cosine a minus theta. So now this is equal to what? Of course, let me think. Another one, because y choose a plus theta. So cosine y, now it is cosine a plus theta. Okay, so cosine a minus theta is equal to cosine a times cosine theta, and then plus sine a sine theta. Okay, so if it's cosine a plus theta, then it's equal to what? Then it's equal to cosine a cosine theta, and we minus sine a sine theta. Okay, so now we can find the mean number of the value that y can choose. So of course, so how do we calculate? Okay, so we're going to find the mean number, actually is to find the mean number of cosine y can choose. So that means we plus cosine a minus theta and cosine a plus theta together, and then we divide 2. So it's like this. So we have, if we plus them together, so sine a plus times sine theta is being cancelled out, and we have 2 times cosine a to cosine theta. So we divide 2 is cosine a cosine theta. So the mean number of cosine we can choose is cosine a cosine theta. Okay, now we're going to prove. Now what we're going to prove is, first let's set, if we set that y is equal to a plus sine, this is actually, we can call it, it's a sine function. And okay, and then sine a, and we times theta. So let's see what the sine function means. So we say this is a sine function, and if we say it's sine of x, so we have 3 choices. One choice is equal to 1, and another choice is equal to 0, and another choice is equal to negative 1. So if it's equal to 1, that means x is positive. So if x is positive, we're going to write this. X is greater than 1. Right? And if it's equal to 0, that means x is equal to 0. So x is equal to 0. And then if it's negative 1, that means x is negative. So x less than 0. Good. So it's stated what the sine function means. So y equals this one. So that means y equals to a plus sine function of sine a, and then we times theta. So that means we're gonna think about a plus theta or a minus theta or a plus 0 multiple of theta. It depends on what the value sine a is. So if sine a, we can say if sine a is positive, so that means a plus theta. And if sine A is negative, so it's a minus theta. And if sine A is equal to 0, then it's just A, right? Because this is a plus 0 multiple of theta. Okay, so you want to know why we set it like this? Because we use this trick so we can prove this problem. Okay, so now let's see. We're going to prove such that cosine y is less or equal to cosine theta. Because actually, if we y choose this value, because every time when y choose this value, it is always in this domain. So y can choose this value. So you know why later we set it is like this value. So now let's see, such that cosine y is less or equal to cosine theta. So what's cosine y now? So it's cosine. It is cosine bracket A. Okay, first let me write it. Cosine y. Okay, so what's that equal to? Cosine bracket A plus sine function of sine A. And then we times theta. Right? Okay. Okay, so let me break it out. So it's cosine A, and we times cosine. See, it shall be sine function of sine A, and then we times theta. Okay, then let's see. It shall be minus sine A, then we times sine function of sine A it shall be sine of sine function of sine A, then times theta. So it's like this, okay? Good. So it is like this. So what's the next step? Okay, so it's like this. Now let's see. So what's this equal to? Now you see here, sine function of sine A could be 1 or negative 1. It is cosine theta, so first theta may be right here. So if it's cosine theta, just this value, right? So now if it's negative theta, just over here, it is still this value. So we can just cancel out, not cancel out. We can just, it's no need to write this sine function of sine A. So right, this part we have cosine A cosine theta. Then what we're going to do is to minus right here. It is sine A times right here if sine function of sine A, so it's 1 or negative 1. So if it's like this, so if it's 1, so it is not right about it. So we can also means we can just take it out of the sign, this sign ruler and this sign ruler. So we can take it out from that. No mind, right? Because it's 1. And if it's negative 1, we also can do it. Why? So first right here, the value is right here. Actually, it's this over this. Okay. Then right here, so it's negative theta, right? So the value so it's becoming negative. So we can just put a negative sign on this value, sine theta. It's fine. So we can just take sine function of sine A out of this sine ruler. So we can have sine A. Okay, now let me tell another thing. Now what we have, right here shall be sine A times sine function of sine A, and times sine theta. Then it's like this. So sine A times the sine of itself. So this, if sine A is a positive, so that's 1. So its part it is 1. So is it nothing, right? And if sine A choice negative 1, so right here it's sine function of sine A, so it's a sine of sine A, so it's a negative 1, so what is it? It is absolute value of sine A. So we can minus absolute value of sine A times sine theta. But theta is 0 to power 2 right now. So sine theta is always positive. So we can also put it in this absolute value. So it is sine A times sine theta. Don't forget to write this absolute value. So if we have this, so that what do we mean? This is when y choose this value, a plus sine function of sine A, and we times theta. That makes cosine y. You see, here's cosine A plus cosine theta. So it's the mean number that cosine y can choose. So that means now cosine y is less than its mean number. So that means, okay, right? Cosine y is less or equal to, because we are not sure of this part. Because why is it? Because this part we have absolute value, so it's always positive. Minus opposite number, so it's always, of course, it's getting less. So we're not sure if this part is getting to 0. So it is less or equal to 1. So less or equal to cosine theta. Okay, great. So now what is it? So now, then it is less or equal to cosine theta. Why is it? Because, you see, cosine times cosine theta, A can choose any number. Because the condition is A is a member of R, real number. So A can choose any number right here, over here. In this polar coordinate system. So if it's like this, that means cosine A, of course, because it's a cosine A, right? So cosine A is less or equal to 1. So every time another theta, right? So you gotta think cosine A. If cosine A is equal to 1, so cosine A times cosine theta is equal to cosine theta. And if cosine A is less than 1, so that means cosine A cosine theta is what? Is less than cosine theta. So that means cosine A cosine theta is always less or equal to cosine theta, right? We also can think another way. Of course, you see cosine A less or equal to 1. Then both sides just times it, cosine theta. That's fine. Just cosine A cosine theta. You see, less or equal to cosine theta. So if it's like this, then means cosine y less or equal to cosine A times cosine theta is less or equal to cosine theta. So that means we have cosine y is less or equal to cosine theta. Okay. So now let's see. So like this, right? Okay. So now we're gonna prove another part is when theta belongs to here's this. Okay. Now theta is a member of, now we're going to prove theta is a member of pi over 2 to pi. Okay. This is the point. Okay, so we're going to draw the cosine picture. So because we are thinking about cosine y. So this axis is y. This axis is cosine y. Great. Now that's the next step. Something like this. Okay. This value is pi over 2. And this value is pi. And this value is 3 over 2 pi. So, I mean, this value is and this value it is pi. Sorry, 2 pi. Okay. I'll write the values right here. Okay? Okay, so now we think about. I said before, right? we're gonna prove this problem. So for any theta, you see, it's for any theta belongs as a member of 0 to pi, and also for any a belongs is the member of real number. So we're gonna prove that there exists. You see. Okay, so I don't read this question. Okay, so what are we actually gonna do? Is that we're actually gonna prove that when A chooses any number, theta, we need to be sure that theta can choose one number from 0 to pi. Can choose one number from 0 to pi. That's such that you see there exists that Y can choose one number from A minus theta to A plus theta. That we're gonna let cosine Y is less or equal to cosine theta. That's the point. Okay, so now theta, we only need to let it choose one number from 0 to pi, and it satisfies, so it's fine. Okay, so if we think about in this picture, this coordinate system, so let's look like. So let's see if theta choices the greatest. You see, now theta is a member of power 2 to pi. So let's think. See, if theta chooses the greatest value, it is pi. No, it's not pi because we can't reach pi, right? So if we can't reach pi, that means theta can choose pi minus d theta. Okay, it is pi minus d theta. So now, and then we also can find that Y is a member of A minus theta to A plus theta. And then Y can reach A minus theta or A plus theta. Y can reach both of them. Okay, so if it's like this, then Y, the domain of Y can choose is 2 theta, right? It's 2 theta because it's from A minus theta to A plus theta. So the domain right here is 2 theta. Okay. Okay, so the domain right here, it says it is 2 theta. So right here, so now theta, we can choose its biggest number, so it's pi minus d theta. So we're gonna just have 2, so it's 2 pi minus 2 d theta. We're gonna just say 2 pi minus 1 d theta. So now because it's the domain of Y, so we just say that we can just say it should be right. It should be 2 pi minus dy. Okay, so now let's see on the axis. So 2 pi minus dy. 2 pi minus dy. Okay, then we move this domain. Okay. So now if we move this domain, let's imagine. So we can think in this picture, every point, actually, in this domain, Y can choose, in this domain, there is the fluff of this cosine function. We can touch the fluff of the cosine function. So that means this is a domain of Y. So then it means now Y can choose this fluff of the whole cosine x function, the whole cosine function. So at this point, if we can choose the fluff, choose the fluff, that means cosine theta only could be greater than this value because the fluff is -1. So cosine theta only can be greater than this value or equal to this value. It couldn't be less than this value, right? So of course, so even if it's equal to, so it's also satisfied, right? So if it's greater than it, of course it's satisfied. Cosine Y is less or equal to cosine theta. Okay. So now what's the next step? So now let's think. If it's like this, so there is a very special situation. You can say it's a different situation. There is a point. A point is that we can imagine. We can think about it in the polar coordinate system. Okay, we can think about it in the polar coordinate system, and in this system we can imagine that 2 theta. Where is it? 2 dy. It's 2 dy actually, right? If it's in the polar coordinate system, it's just over here, and it's over any place. If we can choose different if a is maybe a sometimes is right here, so 2 dy is over here. Okay, some sort of like this. And this is how we're moving that if a are changing, right, is changing. Something like this. And so when it moves to here, that means a choose 0 this place. So if a choose 0 this place, so a choose 0 this place. So what happened? So that means 2d theta, or you can say 2 dy is over here. So that means we can't choose the fruff anymore. So this is a big problem, right? Okay, let's see. Right over here is that a choose 0. So there's some point over here, and there's another point over here, and the fruff is over here. So we can't touch the fruff, right? So that is a big problem. But how do we think about this problem? If we think about it in this polar coordinate system, so if a minus theta is like this is theta, this is a. Okay. Every value of cosine y and cosine theta are the same, so they could be equal, satisfied, right? And if a plus theta, so they're the same, always the same. Okay. So it's always satisfied because now this is a different situation. Okay, it's a special situation that let cosine y is always equal to cosine theta. So it's also satisfied. So we can. So that means we've proved it is satisfied when theta belongs to power 2 to pi. Okay, so here's 2 points I'm going to add. So the first point, right here, when we prove theta as a member of 0 to power 2, we say we can use this algebra to prove it, and we also talk about the graph, right? So, and when we talk about when theta is a member of power 2 to pi, we say because we only use the graph, we talk about a fruff, and there's a different situation, special situation. Then you see we just use this way to prove it. Actually, we can prove it this way because we only use the graph. So actually, if you use algebra, we also can use this step. You can check it. Every step is there's no any problem. You say about this step. So sine theta is always positive from 0 to from 0 pi, because theta is from 0 to pi, right? It's always positive, so it's okay. So we also can use this algebra to prove it. Okay. So actually, now this is the first point I want to add. So the second point I want to add is actually this picture right here. I don't draw really good, and I don't tell you what is happening inside really good. So the first thing is, let's see first. Imagine first we have an angle A over here. So okay, so let me draw over here. I draw another picture so it will be clearly. So first we have an angle A over here. Good. So theta, when we choose the first value, it's 0. It's 0, right? So, sorry, it's 0 plus dx. We can just say that's dx. So, let's draw it. It's over here, maybe. Okay. So, I say this is the theta, okay? So, now, y is a plus theta. We think about when y is a plus theta. Okay. So y is a plus theta. So we draw another theta over here. So, okay. So now you see this is y, right? Okay, so we can actually imagine that something like this. This is a, and this is when it's 0. Actually, it's x-axis, so it's over here. Then we just rotate one d theta, so it's over. Then this y and this is theta. So it's actually theta. Now it's d theta, right? Okay. So the next second, or again say, next second, then theta is getting bigger. So y is a plus theta. So y is move a theta together. Okay. So the point is, we move to when these two guys are symmetry with x-axis. So what we're going to do now is that how can we find this point when they are symmetry with x-axis, right? This is our problem. So we can draw a bisector over here. The bisector of the difference of y and theta. So the difference over here shall be a. So we can draw a bisector over here. Okay, let's see. I think it's over here. Great. It's over here. Yeah, it's fine. It's over here. Okay. Good. Like this, then. Okay. Okay, this is the bisector. So the bisector is moving with y and theta. So this is y and theta, and this is the bisector, right? Okay, great. Then we'll move to here. So y and theta are symmetry with x-axis. That means, let's think. That means this bisector rotate to here. Rotate to horizontal, right? So that means the bisector rotate to horizontal. Okay, so now let's see, where are these two lines? So the point is over here. Let's think, how do we draw this? So we think, what we are actually doing is that we let the bisector move to here, and y and theta move with the bisector. So theta shall be moved the place that are here. So how many angles does it move? So we can decide it by the bisector. So it's this angle, right? Okay. So let dc plus this angle. So first we let this angle start from 0. So then we put on another dc. So that's fine. Okay, so first let's see. When we let this angle let us start from 0. So let's think. We have an angle right here. It's pi over 2. So we can put it over here, pi over 2. So we have another guy over here, this angle. So in the symmetry, we can move it over here. So we can. Okay, so it's symmetry, we can move it over someplace over here. So great. So now this is over here. Good. So this is over here. Then the next step, we're gonna move one d theta, because actually it starts from d theta, and then we let this angle start from 0. So when you let it, so we need to plus another d theta. Okay. So the final point, I think, is someplace over here. Good. Great. So it's over here. Okay, so what's the next step? So the next step, let's see. We know where another guy is, right? Because another guy is symmetry with it, so I can draw a vertical line. Okay, vertical line. So let's see. I think it's over here. Great. Okay. Great, so it's over here. Okay, so actually now you ask, Okay, so let's see. I think one problem. These two guys looks like they're aligned together. They're a whole line. So actually, they're not a whole line. They couldn't line together. Why I say that? Because I'm sure of it. So first, let's see how do I find it? So you see, this angle starts from 0 to here. So this angle is pi, and in another angle, it is 0 from 0 to here, because this is A. All right. This is A, and this is Y minima, because the first second Y, the first moment Y, so this is the first moment theta, so right, minima theta minima. Okay, so then start from 0 to A, so their difference is this part. And we know this part, this angle, actually it is 1. Pi minus A. Good. So let's see. So this angle is pi minus A. So which angle is also pi over A? Pi minus A. So you see this here, it is pi. And from the blue line to the blue line, it is also pi over A. Pi minus A. This angle, the blue line to the blue line, because this is theta and this is Y, right? So, and both of them are the difference, this angle is A, right? Okay, so we know this angle and this angle, their sum is pi minus A. So because these two blue lines are symmetry, so of course these two angles should be same. So of course each of them are pi minus A. Divide 2. So this angle is pi minus A divide 2. Great. And what about this angle? This angle is also pi minus A over 2. So actually, if we want to check if these two lines are at the same line, so we can check this angle and this angle. If they're the same, they're on the same line. If they're not the same, they're not on the same line. And you see, we've already know this angle. It is this angle plus a theta, and we've already know this angle. It is also pi minus A divided 2. So of course we know this part is what? It is pi minus A over 2, then minus a d theta. Right? Great. So of course, this angle and this angle, their difference is a d theta. So of course, they couldn't be at the same line. So we have another thinking example. Actually, you can think about it, but actually, the answer is same. They're still on the same line. So if it's A equal to pi plus d theta. So good. So we can just think about this problem. We can draw another little picture. I just don't draw the circle anymore. It's fine, okay? So first the A, this is pi, right? A is this very small angle. Then so what's theta? Theta didn't change, right? Good. This A, this is theta. And where's Y? Y is over here. Here. Good. Good. So we move Y and theta. We let them rotate. So where's the bisector now? Okay, this is Y and this is theta. So the angle over here, it is A. So we know actually the angle of the bisector, where the bisector is, actually you can think is a power 2. We gotta go there. How many? We go there. Actually, we go there. Go there, because actually over here is a half A over 2. Then we don't forget to plus d theta. So actually, we can say here is pi minus d theta over 2 plus d theta. So 1 d theta, and a half, and another half of d theta. Okay, so it's over here. Okay, now we rotate this guy and this guy and this guy together. Good. So from this guy, move to here. Okay, let me write the angle of this guy. So the angle of bisector. So actually it is pi minus d theta over 2, then plus d theta. So now we're gonna rotate this angle. So what about this angle? Of course, it's pi minus bracket. Pi, we should break it out. So it's pi over 2 minus d theta over 2 plus, sorry, here it should be plus. Okay, plus d theta over 2 plus d theta. Great. Great. Okay, sorry, bracket. Okay, so if we calculate out, it's pi over 2, then what? Actually, it should be pi over 2, then we just minus what? We minus 3 over 2 d theta. Good. Okay, so let's see here. So if we move this angle, so now let's see. If we move y, then where it is, it shall be, we let y plus this guy. We let y plus this guy, right? Okay, y plus pi over 2 minus 3 over 2 d theta. Right. So now what is y? Y, of course, it is pi plus 2 d theta. Okay, so that is equal to, of course, you see that's 3 over 2 pi, and then minus, plus 1 over 2 d theta. Okay, let's see, where is it? Where is it? Okay, it's over here. Fine. So, of course, these two angles, their difference is d theta, because this is actually 3 over 2 pi, and then you plus 1 over 2 d theta. Good. So the difference is d theta, this angle. So that means they still cannot be at the same line. This is another fun problem. It's what I'm gonna add. So this is what I'm gonna add now. Okay, so actually here we have another problem. So actually why I talk about this problem, because there's a different point, is that you see the bisector over here, its angle is greater than pi over 2, so that's the difference. Over here the bisector is right here, so the angle is less than pi over 2. So what is their difference? So actually over here, you see, when we compare these two angles, this is greater than this 1 d theta. So right here, this is greater than this 1 d theta. So why happened this? Because you see, actually right here, when we are comparing this angle and this angle, actually we project it over here. We rotate it over here. So actually we use this angle to compare with this angle. So what's the difference here? So actually, if you try to draw the theta, I don't teach you anymore. So because actually it's totally same. Project over here, then you move 1 d theta. But here's the point: because you move 1 d theta, you're gonna be greater d theta 1 d theta. So if the blue line shall be at the left of this vertex line, then it will be getting to be more closer to the vertex line. So that's why actually you think this angle is less than this angle. So if you project back over here just like this. So actually think if you move A, now it's right here, right over here. So if you move A to any places others, actually that's fine. That's fine. Because this is just gonna be lower. Actually it's also fine. It's just the same, because you can check it like this. You can find out actually when the the bisector is less than power 2, then you see if it's like this, then this angle will be less than this angle. Well, if the bisector is greater than power 2, then this angle will be greater than this angle at dθ. So actually the point is they couldn't be at the same line. Okay, this is what I want to talk about. I've concluded all these situations, including these 3 special situations, on this paper.